Hi guys, so today we are going to start. We are going to solve some problems, okay, on first order, some problems of first order and first degree differential equations, okay, when we are before a homogeneous function, okay. So suppose we have now, okay, as we have already studied that this is okay what we have studied about the homogeneous. So for first order first degree ordinary differential equation, whenever we have suppose we have this is a first order and first degree differential equation like this can be written in this form, okay. So if it can be written in this form, we can just take this dx and m of this one go in this side. So then we can just take this dx, divide everything by dx, okay. Divide everything by dx, okay. If you divide everything by dx, here will be 1, here will be dy upon dx, this expression. Then m of xy go there, go in another member or in the other side. It will be minus m of xy. So this n of xy is multiplying, go dividing. Then you will finish in this way. Okay, knowing that m and n are function of x and y, so this can be written in this way. So if I can write any function or any equation, differential equation in this form, and this f of xy, this partial function here, f of xy, is an homogeneous function, then I can apply this substitution here. Okay, I can apply this substitution and solve this differential equation according to variable separable method for differential equation of first degree and first order. Okay, so this is what we are going to see here. So here we have x sinus of y upon x and dy upon dx, y sinus y upon x and minus x. What we have to do first, so first here what we have to do is check whether this function is homogeneous. Okay, so there is a quick way to see whether this function is homogeneous or not, just by looking at this. See, what is the degree? If the degree of the left side, okay, of here, left side, okay, this part, if the degree of all the polynomial in this equation are the same, then this function is called, or we can say that this function is homogeneous function. Let us see if this degree of this polynomial of all the terms in this equation are the same. Here the degree is 1 of this monomial, okay, like x raised to 1. And here what is the degree? The degree here is the same. It is like 1 1, it will be 0, the degree of this one. So this will be the same, this will remain the same, this is fine. And what else here? And here the complete degree of this polynomial is 1 also, because here it's 0 and here it will be 1 1 1. Nice. What is the degree of this polynomial? We know the degree of this polynomial this polynomial completely will be what? Will be only equal to this one, because here this degree will be cancelled out, okay, will be 0 here, the degree of this polynomial, but here will be 1. So we will take this degree here, 1 degree of this polynomial, and this is 1 and this is 1. So we can say that this function is actually homogeneous. So okay, if this function is homogeneous, okay, there is another way that you can check homogeneous, if a function is homogeneous or not, just by looking at this one. Okay, just try to transform this function and that one. Now that we know this is a homogeneous function, what else we have to do? We have just to send this guy, okay, we can send this expression here in there, okay, or directly we can just apply the homogeneity substitution, like y equal to vx, okay. Yeah, then let us just separate them. Dy upon dx will be equal to y sinus of y upon x minus x all upon x sinus of y upon x, okay. 1 upon y upon x, only this. Now this is okay. So what's the next step? The next step here is just to find y is equal to xv or vx. So find the differentiation between with respect to x of this both side. This will be x dv upon dx plus v, because dx upon x is like 1. Okay, differentiation of x with respect to x will be 1. Now that you found this, you have just to substitute this expression and this expression in here. Okay, we'll call this 1. You can call this star and double star. Okay, substitute what you'll get. X dv upon dx plus v is equal to y is equal to vx sinus of vx upon x minus, this is x, okay, x upon x sinus of vx upon x. Is that okay? So if you see this x can be taken as a common factor. This will be v, okay, v sinus of v minus 1 all upon x, and here sinus of v. Okay, and here I'll get the same, okay, x dv dx plus v. Now x and x will go down, so this will be v sinus of v minus 1 upon sinus of v. And this expression here, okay, here we have v, okay, v can go there, okay, you can just send v there, it's okay. Now what you're going to have, you're going to have this x dv and dx minus v. So from here minus v, so find the common denominator here. You'll find this one and this one. This will be v sinus v minus 1 minus v sinus v all upon sinus of v, and here it is x dv upon dx. Okay, now that you found this, okay, this friend and this friend will be cancelled out. You end with this x dv dx is equal to minus 1 upon sinus of v. Is that true? Okay, what we have to do now, we have just apply variable separable method, like put function of v with derivative of v and function of x with derivative of x. This will be dv, okay, this v, this one can come here, this will be sinus of v, okay, sorry, this will be sinus of v dv. You can call this negative sinus, like sin of the negative, equal to dx upon x. Okay, now you have just to apply integration in both sides, like you will have integration of minus sinus of v dv is equal to integration of dx upon x. Okay, so integration, so integration of sinus, okay, is cosine. Okay, so it means that here, integration not, we have here minus sinus. Okay, minus sinus integration is the same like if I have minus sinus here, it is the same to write like cos of v. If I have derivative of cos of v, it will be minus sinus of v. So this will be this is the x upon x. So it will be cos of v equal to ln, okay, ln of x plus c. What is v? Okay, we know that v, okay, like vx is equal to y. So v will be equal to, vx is y, so v will be equal to y upon x. Substitute here, so you have cos of y upon x is equal to ln of x plus c. Okay, for this equation, it is solved like this. Okay. Now let us go for another exercise. Let us go for another exercise. Suppose we have a function like this. Okay, y square plus x square dy dx is equal to xy dy dx. Okay, how to solve this expression also? Check if it is homogeneous. I'm just giving an example of homogeneous function, how to solve them. Check if it is homogeneous. So this is y square, so degree is 2, degree is 2. And here also degree is 2, so this is homogeneous, clearly. This is fine then. So what's the next step? So if this is homogeneous, the next step is just to put together dy dx and dy dx. Okay, put together. So how it will be, this guy can go there and this guy can come here. It will be x squared minus xy dy dx equal to minus y squared. Okay, so if this is true, you can send this guy down. Okay, dy upon dx will be equal to minus, here it is y and here it is x squared minus xy. Okay, now do the substitution. This is vx. Okay, this will be dy upon dx, differentiate then. What will be this? This will be x dv dx. Okay, x dv dx. Yep, x dv dx. So plus v. So actually you will get just using this. Okay, then just substitute in this formula. Just substitute what is y is vx, and what is dy dx is x dv dx upon v plus v. So you will get this one. You got the x dv upon dx, okay, plus v is equal to, okay, it's equal to minus, here I got vx square all upon x square plus minus x, then v times x. Okay, yeah, if you see this, okay, you can take out or take common. Okay, you can take common x square here, it will be 1 minus v, just like this. Okay, this will be the way. So and here it will be x dv dx plus v. Now x and x will be cancelled out, so you get minus v square upon 1 minus v, and here you got the same expression, dv dx plus v. Okay, plus v. Send this v here out. Okay, it will be x dv upon dx equal to minus, you can just call this minus v square, and this guy, when this come here, you will find the common denominator. It will be minus v plus v square all upon 1 minus v. Okay, so what will we have here? So see, this come here, when you call him here, it is positive, now it will come negative. Okay, just be aware, it will come negative. That's why negative with this will be plus, positive, and this with negative will be negative. Okay, just like this. Then this and this will be cancelled out. You will end like with a expression like this, v1 minus v. Okay, and here it is the same as x dv upon dx. Okay, x dv upon dx. Now see, put v, okay, v function with differentiation of v, and x with differentiation of x. This will be dv upon, okay, v here, it is negative because of this. V is here up, come down, down, go up, 1 minus v. Okay, 1 minus v, it's equal to this x dx, go up, go down, dx and this. So now that you have this, you can just apply integration both side. Okay, integration both side. So this one, this expression will be minus. Okay, this and this will be dv upon v. Okay, and plus, because minus and minus, plus v upon v 1. So dv equal to dx upon x. Okay, now this integration is very easy. Okay, even babies can do. Okay, this integration right now, this will be ln of v plus v. Okay, ln of v negative. Okay, negative because here it's negative, negative, plus v plus equal to ln of x, ln of x plus c. Okay, now that you have found this guy, okay, now that you have found this, so what's the next step? The next step is just to, you have this one, you have this one, so just substitute what is x, what is v. Okay, substitute for v. You can just find substitute for v. What is v? So v, we know v will be equal to, v is equal to y upon x, because y is equal to vx. Okay, then you get minus ln of y upon x. Okay, this is negative, plus v is equal to ln of x plus c. Plus c. Now here you can just play a bit. This one like this, it is like this. Okay, this is the same as I write something like this, minus ln of y plus, okay, sorry, minus ln of y. Okay, then this is down. Nice. This is minus also, minus and minus, it is plus. Yes, plus ln of x plus v is equal to ln of x plus c. See, ln of x and ln of x will be cancelled down, so it will be only, okay, this, we know that what is v. Okay, we know what is v. V is y upon x. So yeah, no problem. I just forgot writing here, but it's no problem. So this will be ln of y, then plus y upon x, it's equal to c. Okay, just like this. This is the solution. Okay, you see what we did. So v is equal to y upon x. Okay, here I put v y upon x. I just forgot taking this input here, but that's no problem. Okay, this is, I just kept this v and this kept this v, then and then I just put y upon x, this v, the same. Okay, how did I finish, like how did I end it in this way? That's the point. So ln of y upon x, it means that ln of y minus, this, take out this minus, forget this minus, just ln of y upon x. It will be ln of y minus ln of x. So minus with minus plus ln of x. So that's why ln of x will be cancelled out. Okay, let us go for the third exercise. The third exercise is, let us see, let us check. Okay, the third exercise is, sorry, it is about x squared. Let us write down. This is x cos of y of x, okay, plus y sinus of yx. Okay, this is multiplied by y, and minus y sinus of y upon x minus x cos of y upon x. Okay, and here it is x dy dx equal to 0. Okay, long time, long exercise. And see, this, let us solve for this one. So how to solve this exercise? That's the point. See, when you have an exercise like this, the first thing you have to understand is, let us check first if it is just, how can I say, if it is homogeneous or not. Okay, This exercise can be solved also applying concept of non-exact non-exact equation or differentiation. We can also apply. So, but when it comes time, we are going to solve with the same expression or the same equation, but with a different method. That's okay. Okay, how to solve this? See, let us see what will be here. As I was saying, okay, whenever the degree of this polynomial is equal to the degree of this polynomial here, okay, so we can say that this function is homogeneous. Let us check. This is 1. When it multiply this, it will be 2. And when this multiply, this will be 2 also. This will be yx, 1 with the exponent and the exponent 1. So 1 plus 1, 2. And here y squared, this will be 2. Okay, so here the degree of this polynomial will be 2. It's fine. But now check the degree of this polynomial too. Okay, how about this one, Veloso? How about this y upon x? So y upon x, the degree here will be 0. So the degree of this polynomial will be taken as the highest, okay, the highest power, or the highest power of this polynomial. This will be the degree. And for this one, you'll get also, this is y, x times y, degree will be 2. 0 here, so it will be 2 degree, and here times this will be 2. So all this expression had the same degree 2. So what does it mean? It means that this function is, or this function is how can I say, it's a homogeneous function. So dy upon dx, okay, this one go there and this one go downstairs, okay, go down. This is what we are going to have. So dy upon dx will be, okay, positive y sinus of y upon x minus x cos of y upon x, okay, or multiplied by x. Multiplied by y. Okay, I just changed it. Sorry, I just changed it. This is y, so this should be this expression. X cos, okay. But it's okay, we have just to put this plus. If I put this plus, so it will be the same, y sinus and x cosinus, no problem. Then this expression down, this will be y, okay, y sinus of y upon x minus x cos of y upon x, and this is multiplied by x. Okay, knowing that this is a homogeneous function, so we can say that y is equal to vx. So it means that dv, dv dx, x dv dx plus v will be equal to dy dx. Then substitute in there, you have x dv dx plus v is equal to, where you find y, put vx, okay, vx, put vx. What will you have? So this will be vx, okay, sinus of vx upon x plus, okay, plus x cos of vx upon x time, this is vx, all upon vx times sinus vx upon x, then minus x cos vx upon x, okay, all upon x. So if you just simplify this thing, you will have only a function, okay. In the left side or in the right side, you have a function of v only, okay, because see here you have x will be cancelled out, okay, take common x, will be cancelled out, so you are going to have only v sine of v minus cos of v, Okay, and here you have v sine of v plus x cos of v, okay, cos of v time you will multiply by v. Okay, this is the expression that you're going to have. Now from here, all you gotta do is just yeah, it looks like a little bit complicated, so all you gotta do is just to change this, okay, this expression here, send out. So this will be v sine of v plus x cos of v plus x cos of v, and sorry, here there's no x, no x in here, because x you have already removed. You have already removed x, so no x, sorry. Okay, cos of v time v. Now it's okay. This is all divided by v. So this, when you call this guy out, what will happen? This will be minus v square sinus v and plus v cos of v. Okay, all upon v sinus of v minus cos of v. Is that okay? Now it's fine. Looks like long, but we are going to simplify and to make it easier. So this will be x dv, okay, x dv upon dx will be equal to v square sinus of v plus v cos of v minus v square sinus of v, sine of v plus v cos of v. Okay, v sinus of v minus cos of v. Just fine. Now what is the next step? So the next step is you have here this one, you can just cancel out this and this. Okay, this will cancel out, will be cancelled out directly. So this x come here, nice. Yeah, so what you're going to have, x dv upon dx is equal to 2v cos of v upon v sinus of v minus cos of v. Okay, this is the expression that we are going to have. Now from here, what you're going to have, we just have to put together the fraction, or how can I say, all the member or the terms that have v with the differentiation of v, function of v with differentiation of v, function of x with differentiation of x. So this will be dv upon, this guy will come up, okay, this will be v sinus of v minus cos of v, all divided by 2v cos of v, okay, 2v cos of v. This is equal to the same dx upon x. Now what you have to do, this is this expression that you have here, okay, you have there, you can separate this as a v sinus of v upon 2v cos of v, okay, dv, then minus cos of v upon 2v cos of v dv. This is equal to dx upon x. Okay, yeah, in this way, so you can just simplify this, and here you can simplify this and this. What you are going to have, you are going to have 1 by 2 tangent of v dv minus, and here you have 1 by 2 1 upon v dv is equal to dx upon x. Okay, now you can integrate. Okay, apply integration here, and integration here. Okay, integration. Tangent integration of tangent, we know, okay, it is sinus upon cosine. So this is, sorry, this is the same as 1 upon d of cos u, and this must be negative upon cos of u minus 1 by 2. This is dv upon v, and this is dx upon x. So this one will be minus 1 by 2 ln of cos of u. Okay, ln of cos of u, then minus 1 by 2 ln of v, then ln of x plus c. Okay, everything is ln. So here you can also see that this one can come here, this one can come here. So this will be 1 by 2 ln of here, like 1 upon cos of v. Okay, cos of v minus 1 by 2 ln of v. Okay, you can call this here also ln of x equal to c. Okay, you can just call this one, call all together. So you get 1 by 2 ln of sec, okay, ln of sec of v minus 1 by 2 ln of v minus ln of x equal to c. You can just put this all together. If you put this all together, it will be ln of sec of v to the power 1 by 2. Okay, this is divided, okay, this is divided by, okay, v also with the power 1 by 2 time x equal to c. How to arrange this one? So this one can be written like this. Okay, this will be root of sec of v upon v, okay, time 1 by x is equal to c. Now from here, this expression, like you can see, okay, you can come here and this Euler can go there, or you can just put Euler. Okay, this two exponent Euler, this Euler to exponent of ln, and this Euler to exponent of c. This will be only this. Okay, this will be root of sec of v upon v time 1 upon x equal to Euler to the power x is the same of c. Okay, so what is v? We know that v is equal to y upon x because y is equal to vx. Okay, so substitute here what you are going to have. You're going to have this root sec of y upon x upon y upon x to 1 y upon x time 1 upon x is equal to c. You see this expression here? Okay, if you feel like you can do also some simplification more, so okay, because this expression is root of sec of y upon x, okay, and here you have this one, root of y upon x time 1 upon x is equal to c. See, you can just play a little bit with this also. This will be this can be also written in this form if you feel like. It can be written in this form. So how root of sec of y upon x, okay, all upon y time root x upon x. So root x upon x equal to c, and this one can be written in this form also. So it means it's upon you. Okay, it's upon you. So these are some brief explanation. So if you feel like you want to solve more exercise, you can solve this one. Okay, I will let some exercise to you to solve too. So you can try for this one. Okay, x power 3 plus 3xy squared and dx plus y cubed plus 3x squared y, okay, and dy equal to 0. You can try for this, okay, try for this exercise. If you can solve, just try to solve this. Or you can also try for this one, minus x sinus y upon x, and dy upon dx equal to y sinus of y upon x minus x. What I want to say is that once you are done, let me say like, once you are done with this, okay, you are done. Once you finish, you just got this space or this step, you are finished, you're done. You can finish like this. But if you feel like, you can just do some more simplifications and go on and on according to what you feel like you can do. So thank you very much. Next section we are going to start solving next session we are going to start solving different exercise like we are starting next lesson. We are going to start this I just forgot, guys. Sorry, I just forgot. But we are going to start exact differential equation. Okay, exact differential equation and non-exact differential equation. And with this method of knowing the exact, when a function is exact differential equation and non-exact differential equation that you can reduce to an exact differentiable equation, we will solve also some of these exercise. I will repeat, okay, mainly this for homogeneous function, because any homogeneous function, okay, any differential equation that is holding an homogeneous function can also be solved by this by applying this concept of exact and not exact differential equation. So thank you very much. See you when I see you. Oh, okay. So, and if you feel like you can solve also for this, try for this one. If you feel like you are not getting the answer, so just let me know. It's okay. These are some particular non-homogeneous function that you can reduce to homogeneous function. Okay, you can reduce in this one. There are some just points that you have to do. Okay, thank you very much, and see you when I see you.